Okay, so today we are going to work with applications of trig functions, and we're going to start with the angle of elevation. In the angle of elevation, so if I'm looking straight ahead, the angle of elevation, if I looked up to the projector, that would be, so looking straight ahead and then looking up, that would be the angle of elevation. So I have just a picture here to show you. So if you have this baby and he's looking at Abe Lincoln's eye, that angle of elevation would be right there. So like, if they were looking straight ahead, that would be that. And then if they looked up, that would be the angle of elevation. And then like the hypotenuse of this triangle would be like the eyesight of the baby. That's pretty basic, right? So let's do an example with it. Who can raise their hand and tell me if they've been to the Space Needle? Where is the Space Needle? Seattle, yes. So let's say all of us are in Seattle and you are looking at the Space Needle. You just found out it is about 605 feet tall, and as you look to the very top, your angle of elevation is 60 degrees. So what we're going to do with all of these problems today, and what you have to do in your homework, is you're going to want to draw a lot of pictures and figure out what trig function you want to use. So we know that the height of the Space Needle is 605 feet. The problem tells us that. And then, yes?
On these problems, we're going to have factor things like you're 5 feet tall, so it's really nice.
No. And then, so then now you're looking at it. So let's say we're looking at it from here. And the angle of elevation to the top of it, they told us, is 60 degrees. How far are you from the base of the Space Needle? How would we figure that out? So here's the base. Here we are looking up. That's our angle of elevation. Wouldn't set up a ratio. What have we been learning about the past, like, 2 weeks? Inverses and trig identities. So what trig identity do you see here? So we're trying to find this side, right? That's x we're trying to find. So couldn't we say that tangent of 60 degrees is equal to opposite over adjacent? Because that's tangent. Does everyone see how I did that? So I want you to solve this problem and get out your calculators. Yes, I would assume. Make sure, one thing to note, what do you want your mode to be? Mode. So check that before you do it, because I'm assuming many of you probably have it in radians. And then once you get the measure of x, you can shout it out. 3.
Oh my god.
Okay.
So funny.
So Aaron, what'd you get?
I've not done it yet.
Okay. Amelie, what'd you get? 0.29, so we'll just say about 349. And in the context of this story, what would our measure, what is our unit of measurement? Feet. So if you're looking up at the Space Needle with an angle elevation of 60 degrees, you would be 394 feet away from the base of the Space Needle. 49, sorry. Thank you. And there's a few simple ones like this in your homework. So if you're able to do that, then you can get a few of those problems on the homework. Has everyone got it written down? What? Oh, so let's actually, I just skipped a few steps. So we're here, right? That's what we have. So then how do you get x alone?
Multiply by x.
Yep, so this is how I would do it. So I'd say tangent of 60 times x, to get rid of x here, I multiply. That's equal to 605. Now I still have to get x alone, so how do I undo this? Divided by tangent of 60 on both sides. And then if you type that in, you should get about 349. Is that what you got? Good. So in addition to angle of elevation, we have angle of depression. Who has heard of the quarries here in St. Cloud?
Oh, the one we can go like jumping off.
Yep, so there's a park in St. Cloud, and they call it the quarries, and it's actually a bunch of like cliffs, and people go jump off them. The water's like 150 feet deep, and I've been there. It's super, super fun. So this summer, if you're ever looking for something fun to do with your friends, you should Google the quarries in St. Cloud because it's a lot of fun. And this St. Cloud. And this is a picture of what it looks like. That is like quarries in St. Cloud.
But the water is different. There's like two tones. Like the one on the dog.
Oh, that was me adding my for this problem. So the angle of depression, so this guy is standing up there, and his angle of depression to the dog would be right here. So his horizontal view, that's this. Like if he's looking straight ahead, that's his horizontal view. Then if he looks down at the dog, that would be the angle of depression. So going from your horizontal view down, whereas elevation we were horizontal and looking up. And the way we solve angle of depression problems is a little bit different, and I'll show you why in the next slide here. Okay, Cape Hatteras Lighthouse. Has anyone heard of that? I didn't think so. I hadn't heard about it either. I was Googling it last night when I was trying to find problems. And it is the tallest lighthouse in the United States, and it's in North Carolina. So, this problem, the angle of depression from the top of the lighthouse, which is 190 feet tall, to the ground is 84 degrees. How far is the smiley face to the lighthouse? So this is our problem, and it's an angle depression problem. So let's try to solve it, how we'd figure this out. So they're telling us the angle of depression from the top of the lighthouse to the ground is 84 degrees. So I have angle 1 here and angle 2. Raise your hand if you think the angle of depression is angle 1. Raise your hand if you think it's 2. It's actually 2. Our angle of depression is right here because that's where you're looking straight ahead and then you look down, and that is how they measure the angle of depression. So that would be 84 degrees. What kind of angle does this form? A 90 degrees. So can I figure out this angle? What is it? 6 degrees because we did 90 minus 84. Supplementary angles that add up to, or complementary that add up to equal 90. And then we also know that the lighthouse is 191 feet tall. And we're trying to find this right here. I want you to try to solve it. How would you solve that problem? Am I using 6 degrees or 84 degrees to solve this? 6, good. I like to hear that. So we can say that tangent of 6. Notice these are like the triangles we've been working with are trig triangles, and we're just solving them the same way. And tangent is TOA. So opposite over 191. Did anyone get that far? And then to undo this, we say tangent of 6 degrees times 191 is equal to x. And someone that has their calculator, what does that come out to equal? And then in the context of the story, so the 20 goes here. Is it 20 meters, 20 yards, 20 feet? So the smiley face is 20 feet from the base of the lighthouse. Third hour, someone asked me if this angle would be equal to 84 degrees. And who can tell me if this angle would be equal to 84 degrees? Yep. So this would be 84, and this angle here would be equal, well, that wouldn't be correct, would be 6 degrees if we drew that. And that's from, it's like a geometry you probably did in 8th grade. My 6th graders were doing that. These are interior, alternate interior angles. That's why you can say that they're equal. Okay, so those are like the pretty basic ones. Let's move on to the Superman example. And I took this one from Mr. Server. I think it's pretty cool. So I want to give you like a minute and a half to get started on it and see if you can try it or do it, and then we'll go over it together as a class. So take about a minute and a half to do it. Okay, so let's try this together. So the first piece of information we get is Superman is flying 100 feet overhead. 1,000. So that would be 1,000, right? And Superman would be right here. As Lex Luthor chases Lois Lane, they are all headed in the same direction towards the flux. Superman calculated that the angle of depression to Lois is 55 degrees. So let's say Lois is right here. There's our triangle. And the angle of depression. So when you do angle of depression, I think it's always helpful to look at the horizontal view. So that would be if Superman was looking straight ahead. And the angle of depression is 55. So that's that angle, right? And what we're trying to find with Lois is we're trying to find like this total distance. So what is 90 minus 55? 35. So we have that angle, and we have that side. We need to find this side length, how far Lois is. Can you figure that out? How would you do that? What does x come out to equal? Yes? Yep, so what we're going to do is we're going to find out the total distance. So that's where Lois is. And then we're going to actually, the second part is we're going to go in here and we're going to figure out where Lex is. And then that will give us this distance, so we'll subtract them to see how far apart they are. But we're going to first work step by step. So what does x come out to equal? How far is Lois? Who got that? How much? Tangent of 35 times 1,000. Who did it? 700.207. So let's just say 700, okay? So 700, and we're doing feet. And then the next part of the problem tells us the angle of depression to Lex is 65 degrees. So we're going to draw another triangle, and that's for Lex. This should be like a 90-degree angle. It doesn't probably look very to scale. So the angle of depression, remember, are horizontal looking down, so that's this angle. It's not the inside. So then what does that inside angle become? 25 degrees. I'm running out of room. So now find this distance. This would be Lex's distance. $234. So that's here.
No, I'm sorry. No, 244 is the total once you subtract 700.
Oh, so what's what?
466.
466. So then the rest of the question, to answer it, says, how far is Lex from Lois? So this is Lois's and this is Lex's, so we want to take 700 minus 466. And that is 234, isn't it?
Yeah.
Not too bad. Not any new math. The only thing you might struggle with when doing these problems is actually setting it up and trying to figure out the setup of it. So I want to make sure you have good notes. So if you are still taking notes on this, let me know. Otherwise, if you're ready, put your pencil down so I can know to move on. Oh, is everyone ready? Okay. So then we're going to do one more before homework, and we're going to do this one. So from the top of an 80-foot building, a woman observes a car being chased by a police officer. So first part of my problem, I'm going to draw a building. And it's an 80-foot building. And here's the observer. So that would be for angle of depression. The angle of depression from the woman to the car is 30 degrees. So say the car's here. And it's being chased by the police officer. So the angle of depression from the woman to the car is 30 degrees. I want to draw that better. Remember, angle depression, that would be your angle of depression, right? So the angle we're actually working with is 60. In your calculator, you're going to need to do tangent of 80 is equal to, or tangent of 60 degrees. You could, but I think doing it this way gives everyone the practice because it's not always going to work out that way. So tangent of 60 is equal to opposite over 80. What does that x come out to equal? 138 feet. Now we got to figure out the police officer. So that when she looks at the police officer, her angle of depression changes to 20 degrees. So that's this, which means we really want to be looking at 70 degrees. I want everyone to figure out how far the police officer is from the building. How far is the police officer? The car's 138 feet from the building. The police officer is how much? 219 feet. So if we want to find out how far the police officer is from the car, what would we do? 219 minus 138. Isn't that 81 feet? 81 feet. And so this one and the Superman one, those would be like the hard ones in your homework. So if you understand and took good notes on this, then you should be able to do those harder ones in the homework. Any questions about how we set it up, how we did anything? Things that are confusing? Okay, so now what we're going to do is I want you to write down the homework, and then we're going to look at number 2 from the homework. So after you write it down, go get a book. And there's something important we need to talk about. But you will have almost a half hour to, people finish it in other hours. Then open your book up and look at number 2. Okay, so let's look at number 2. From a point 100 feet from its base, the angle of elevation of the top of the Arc of Septimus Severus in Rome, Italy is, so this, we're talking about angle of elevation. And this is the, we'll just say the arch. And they're telling us the angle of elevation is 34 degrees 13 minutes and 12 seconds. No. Does anyone remember how to type that into your calculator?
There was a way to do it.
So let's learn it. Let's do it together. I want everyone, because you're going to need to be able to do this on the test, and it's important for your homework too. So first thing you want to do is get your calculators out and then type in 34. And then you're going to say second, and then it's the blue, or on mine it's the blue button. Otherwise it might say angle in yellow. You want to press that. And then you're going to say 1 because that's the angle symbol. Then you're going to type in 13. So you're going to go 34 second angle.
It's the alpha.
Yep. So then if you type in 13, then you need to go back to your angle button and go to 2 because that's your minutes. And then type in 12. And then the seconds is weird. You have to do alpha and then press the plus sign. And then the measure they want you to use to solve this problem is 34.22 degrees. So use that angle measure to solve the problem.